Okay, so from last week, what are we learning is complete square, right? So whenever we met kinds of quadratic equations like ax squared plus bx plus c equals 0, these kinds of format. So any have the two quadratic equation like these kinds of format. Firstly, we needed to transfer into these kinds of format. Make sure one side is 0, right? Equation, and the left side is actually made of three terms, right? So they have the second degree, 1 degree, and the constant number, right? So if you quadratic equation, of course, a is cannot equal 0. So whenever you can find these kinds of expression, of course, B possibly can 0, right? C possibly can 0, but A definitely cannot be 0. This one cannot be 0. B possibly 0, C possibly 0. So it's fine because at least this one term should be exist here. So whenever I have these kinds of quadratic equations, we can use the complete square. Last week we can complete square, right? Complete square. Because all these kinds of format can transfer into what? A. So x minus b over 2a, actually plus square equals something, right? Actually is b squared minus 4ac over 4a squared. 4a, not 4a squared here. But whenever so all complete these kinds of square can transfer into these kinds of format, a right part like this. So when we move a to here, like this, right? So x can be transferred into like these kinds of format. Is a very critical part, right? So suppose here is greater equal than 0 because of bottom, the denominator part is 4a squared. The numerator should be greater or equal to 0, so we can square root out of there, right? So suppose they are greater or equal than 0, so we can square root both sides. So you can got x plus b over 2a equals b squared minus 4ac over 2a, because the bottom is 4a squared, the square root will become 2a at the bottom. Top part plus minus here, right? So like this, what do we say? We use this one called discriminate. We can use this one to judge if they have solutions. If they're greater or equal than 0, they do not have solution. They have solutions. They are less than 0, they will not have solutions, right? So x could be equals to negative b plus minus square root b squared minus 4ac got over 2a, right? So it means first, whenever we have these kinds of equation, we need to find out a, b, c, right? And then we need to use the discriminating to judge if they are greater, equal than 0. If yes, first, second, and the third, we can use these kinds of formula to get the solutions. We got the solutions, right? So whenever you guys can use these formula methods to get it. So like this example, let's see first example here. So you can got A is 3, B is 1, C is negative 3, right? So firstly we find this one. Second one, actually first is right here. We find the ABC. And second one, we use the discriminate to get b squared 1 minus 4ac, right? So you got it here 4, 36, and 37. So it's greater equal than 0. So the third step, we can get x is negative b is 1, right? Plus minus square root this part, actually 37 over 2 A 3, right? So you got once you 3 step, you find the solutions, right? The same here. See the second example. So first we do the proper transform first, right? Like I say 2x squared minus 9x minus 5, you got 0. So you got A equals 2, B equals -9, C is -5. Right, so we use to discriminate b squared minus 4ac. Sometimes we use the syllables like this one called square. No, not square. We call this one like small triangles, right? We always call discriminate and describe these kinds of discriminate. All right, so you can get -9 squared minus 4ac. So you can see 81 plus 40, right? So you got 121, right? So you can get the x is -b plus minus square root 121, right? Over 2a. So here is 9 plus minus 11, right? Over 4, right? So you got 120 is 5. The other one is half. -half, right? So easily you get results. Same step here. So you needed to x squared minus plus x plus 1, right? Equals 0. So you can see A equal 1, B equal 1, C also equal 1. What about discriminate? So you got a 1 over 4, 1, 1. So you negatively less than 0. So it means no solution for this equation, quadratic equation, right? All right. So pretty quickly to we're understanding this part, right? Anyone have questions here? So homework part actually is the same. We first need to try to let you guys try to complete the square. Actually try to let you know how we get these kinds of formula, right? This complete square actually we try to deduce to get these kinds of formula. So right now we just use it directly. So this is called general kinds of formula. So you can fit it all the case about the quadratic equations, right? All right, so we move this part. This is what we learned from last week. So let's go a little bit more details, more topics. The B's, just like I say, this is we call discriminate, right? Discriminant. And when they are positive, they have 2 solutions. When they are equal 0, they have 1 solution. When they are negative, they are no solutions, right? So that's what I will teach you right now. All right, so let's move further. Okay, so actually, just like we say, we want to a little bit further. We're trying to find, just like we say a squared, ax squared plus bx plus c equals 0, right? So right now we extended a little bit further. We say, okay, this is equal 0. We split this part. Can we split this part? Left part we say y equal, right part is y equals 0. Right, we see actually we try to introduce a function. We know the linear line function, right? So ax equal ax plus b, right? Right now we saw this is slope, this is y-intercept. Did you guys still remember this part? The same, we into the function like this one. So actually not equal 0, possibly equal multi-numbers. So let's y actually change with the x. This one will also like this. We can extend this part. So it means there's 2 variables here. One is x. So whenever you input one x, so whenever given an x, when put this formula, They will generate in y. This is value, right? They generate this kind of value. Actually, this is the y. So it means y changed by the x. Whenever you given an x, the y will come out of one data, right? So this is just like earlier, what are we doing? Say y equal ax plus b. This one, you know that one. So in this xy kind of coordinate system, so you can draw kind of this thing, and this the slope is a, right? The y-intercept here is b. You guys know this one, right? Definitely, well, definitely, well, much better than this what we have. But what about this case? What about this case? When y equal ax squared plus bx plus c. Earlier, we only learned this part. Right now, we go higher level. What kinds of this part? Right? What is this one? All right, so we give a very quick example first. Suppose here we give y equal x squared. We'll see what simplified case first. Just like a is 1, b, c equals 0 is this case, right? So let's see what kinds of this drawing will be. This is x, this is y, okay? Okay, so can you guys do this one? So when a 0 equals 0, right? When a 1 equals 1, when a -1 equals -1, when they are -2, here is 4, okay? So let's see this drawing, just like the example here. So when the x equals 0, when the 1 equals 1, when the 2 equals 4, when the 3 equals 9, right? When the -1 is negative, it's 1, 2, positive 4, actually here, not this one. It's this one right here. And when the 3 is 9, go up here, right? So let's link together. I use a graph. So link together. It's like this. They pass through here and go here. Like this kind of curve, right? We call parabola. Parabola, right? Like a ball bouncing on the ground and bouncing back. Okay, looks like a parabola. Did you see this kinds of curve? This kinds of curve. They have a minimum value. They only touch here, right? Like touch there and bounce back. They are not linear line. They are not a straight line. They are not straight line. It's curve, right? It's a curve. They looks like they are symmetric here. You can see this one and flip over here. They are just like left hand, right hand. They can overlap together. If you flip it, if you just list a paper, this is like the symmetric, right? They can flip over here. They are overmatched. They are matched, just like a left hand, right hand. If you flip together, they are matched to each other, right? You guys see my screen here? So left hand, right hand. If you base on the middle line, they will match, overlap, symmetric. So this is symmetric. Symmetric exile, right? Exile. So this is the symmetric exile. So this one is, this line is a linear line. We call this line what? X equals 0, right? Did you see this is x equals 0? And actually this is the parabola. So y equal x squared. You can curve this one. So they have this one, if you extend even, it's go a little bit further, right? So here we'll go maximum. They will go positive infinity. Here also go positive infinity. They have a minimum value here. Minimum value is 0, 0 here. Looks like this is the vertex. So this is the point, the minimum value. So y minimum value is 0. They have symmetric is x equals 0, right? This is symmetric. And they go this way. They have y-intercept. This is a y-intercept. At the same time, this one is y-intercept, right? They cross this y-intercept. Is 0, 0. They also have x-intercept. This is x-axis, right? They have intercept here. Also 0, 0. So this point actually have 3 points here. This is the vertex. Also y-intercept, x-intercept. They have the x-metric axis. They also have the minimum value. And this mouth is open up. Mouth open up, right? Open up, right? Right? So it's interesting. So this is called parabola curves. This is very simplified situation. All right. So let's see what these kinds of thing looks like. All right. Let's see this thing looks like. All right. So I will clear screen. Clear screen. So what do we see here? What do we see here? We do some proper adjustment first. Suppose this one is equal 0. All right. Suppose so we go back, this one became the quadratic equations. So you guys can do the quadratic equation like last week what are we teaching. So this one change into what? We do the per complete square. All right. So plus 9, right? So this is 6 divided 2 and square. -6 divided 2 and square. So it became 9. So we minus 9 again and copy down 8 equals 0. Right? So this is the complete square. We match up here. So this is the initially. So if you go this one gone, so we're still like the initial one, right? So this one change into x minus 3 square minus 1, right? So actually we can do like this way, right? Y equal this one, y equal here for this one. So actually we change into like this. This is a complete square. Did you guys can do that? You guys can do this one, right? Okay, so this one make us easier. Make it easier to drawing. So when x equals 3, here got 0, right? This part 0, -1. So here, this is 1 dot is right here. So 3, -1. X equals 3, y will equal -1. So y equals 4. So here equals 0, right? 5. So here got 3. You got 6. Here got 1. So here got 3 square, right? So you got 8. What about opposite side? So let's go up. So if they are negative, 2. If they are 2, so you got a 0, right? Because -1 square. So you got a 1. What y equals to? Here is 4 square, so it became 3, right? So you got the 0. So here got 8. Do you see this match? So this one is the middle line. This one is 0, 8, 3, 0, 8, 3. So you got when they are got a 4, here is 0. When they are -2, also got 0. So you got 3 point here as well, right? And you got a 5, you got the 2 more up here, you got a 3. So you got a -1, you also got 3. When you got 0, you got an 8, right? And here got a 6, you got an 8 as well. Did you see? So you go, they have a match kinds of, just like a symmetric kinds of situation. So you can see, let's graphically pull this together. All right. I didn't draw so good as before, right? So, but it's like this way, right? What do you think? What do you think? It is called parabola as well, right? They are not linear line. The mouth open up. Okay. First, mouth open. Mouth open is up, right? Mouth open upside. Second, we see the symmetric line. Symmetric line is what? X equals 3. Do you need to see what? Just make this part become 0. Because x minus 3, this is something square. The minimum value of this part will be 0, right? Because any number square of greater or equal than 0. So the minimum value actually is 0. So when they make 3, so it's the minimum value. So y would become the minimum, right? So you can see this dot is the minimum. So we got a symmetric value x actually equal negative b over 2a. Here is negative 3. You can put it's positive 3. You can see this one. This is symmetric value. Actually, this one is come from negative b over a. All right. So if you even find b, a, you can also get this data quickly. The third one, we find the x-intercept. X-intercept is one of the 2 0, the other one is 4 0. So x-intercept, x1 equal 2, x2 equal 4. How this come from? Actually, this one is come from what we learning earlier is make this one equal 0. So we can use the quadratic formula solution to get it. Also, we can use the factor methods if you can factor, right? Also, you can make this equal 0. So x minus 2, x minus 4 equals 0. So one of the data is 0, 2, the other data is 4. So the point here is x-intercepts. Right? So actually just make this part become 0. So you can get 2 data. Third, fourth, what's the y-intercept? Y-intercept is only this point here, right? Y-intercept means x equals 0. When x put 0 inside, you can say this is C. 0, C. So C is ready. So it's 0, 8. 0, 8. All right. So we can get this information. Another thing, we got a minimum value. This minimum value actually exactly located on this symmetric line, right? The bottom of it. So just like I say, when this is something square minus 1. So this is minimum value is 0. So y minimum value is when the x equal 3 or exactly equal this 1, this part will become 0. They are minimum value. So you can get negative 1 here, right? Actually, it's exactly this point we call vertex. So this is 3, x equals 3, right? Y equal negative 1. Vertex. So that's the thing we're learning here is when we try to graphing a quadratic equation, we can use the x, y kinds of methods to find multi-dots and link them together. We can find out what their mouths open up and down. Actually, I can tell you this one. So when the a greater than 0, mouth will be open up. When a is less than 0, what's a? A is right here, right? The coefficient in front of this one. When they are less than 0, the mouth open will be down, like this. Flip down, it's not up. So based on this one, you can judge the mouth up and down. Based on this formula, you can find the x-axis. And based on the equation, quadratic equations, we can find the x-intercept. You can find y-intercept. You can find their vertex. So actually, we extended a little bit here. So for general case, something like a squared plus bx plus c. Right? So this is the general case. This is our typical case. So this one we can we can completely have square is like this. Right? Plus what? 4ac minus b squared over 4a. Right? Is it correct? So you can see this one. First, we need a data. To find this mouth is open and down. Right? Second, we can find the symmetric way Excel is based on negative b over 2a. Actually, it's make this part become 0. So you can go to here. You can go to here. Based on this part, you can go to here. Right? So 3, we make the y become 0. We can go the x-intercept. You can find the 2 xy intercept. Sometimes they graphing like this way. They have not x-intercept. It means this part, so means the b squared minus 4ac is less than 0. Sometimes they don't have x-intercept. No x-intercept, it means they are just away from the Excel, right? So we need to judge this part based on here, based on this discriminant. So the third one, actually find the intercept here. So sometimes yes, sometimes no, sometimes only 1 point, just like right now, y equal x squared. You can see the graphing actually is somewhere here. Let me do a graph here. Is something like this, right? They only have 1 dot here. Sometimes just 1 intercept. So y-intercept actually need based on the previous values. We need to judge this discriminant. If they are greater or equal than 0, is greater each row have 2 intercept. If they are equal 0, only 1 x-intercept. If they less than 0, there's no x-intercept, right? So that's our this part. The fourth one, so we will go to find y-intercept is 0c. So you need to determine this c value. You can see find value. And then we find the vertex here. So x equal what? Make vertex actually is make this one find their maximum or minimum. So you can see when the a is greater than 0, because of this part is always greater or equal than 0, right? When you time a positive number, there's still minimum number is 0. So you can get a minimum value here. But when a is a negative number, so this is a positive number, so this whole number became maximum value. Maximum value is 0. So you got y, maximum value is this part as well. So interesting part, right? Interesting part. So you needed to know a greater or equal 0, you have the y have the minimum value. When a less than 0, y have the maximum value, right? Y have maximum value. When x certainly they have maximum value. So value, so whatever they are, they always have a peak. This peak is the valley, the bottom of this valley, or peak of this. When the maximum is the peak of this mountain, right? When they are looks open up, this one is the bottom of this parabola. But what's the peak? So we can see we make this one became 0, right? So x will be equal to this one. So what about y? Y became 4ac minus b squared over 4a. You can see make this became 0. So this whole term will become 0. So the rest will be this one, right? So here I have negative here. Make sure I'm writing here not so good. Make sure negative in front. So you make this term become 0. The rest, all these parts became 0. So whole term is left this part. Okay. So that's why I want to introduce in save the time to talk about this a little bit. This is very critical. So in near future, you can extend it to A, B, C, try to see what's going on there. All right. I hope you guys can save this screen. Save this screen, all right? Okay, so actually we talked about this one already. Okay. So I will not talk about complex number. Complex number will left the letter 1 for you goes to the algebra. Because of earlier, I like to teach a little bit more of complex number. Okay, so new topic is done. New topic is done. I can go back a little bit, make sure you guys can print this screen here. One more time, I also say screen here. So let's spend the rest of time go to the exam. Do as small as you can, and you can do that one more time actually homework. All right, sounds good, everyone. Let's go to the quizzes now. Okay, take your time. I don't think it's really you have finished, but just take time finish. I said pretty long kind, so let's go to the quizzes part. So prepare your some draft paper, and we still go to the quizzes. Okay, go to the quizzes. All right, so can you guys see my screen here? Go to this website, use this code, and try to begin. All right, sounds good, everyone? All right, so I pause my recording right away. Let me pause my record. Stop.